From now on, I will talk about the general formulation of non-degenerated perturbation theory. And previously, we studied for that the energy eigenvalue for the perturbed Hamiltonian should not be degenerate. If it is a degenerate, and if we assume that the degenerated energy state, then the first order or a high order perturbation energy term becomes diverged. That is violation of the first criteria of the perturbed Hamiltonian should be small comparing to the unperturbed Hamiltonian. So, and here we will start for the non-perturbative exactly solvable eigenvalue equation. And H0, N0 is that exactly solvable eigenvector. En0 is that exactly solvable energy, well-defined energy eigenvalue, N0 here. And here we define that H prime is the perturbed Hamiltonian. So in the general Hamiltonian is that divided by the unperturbed and perturbed Hamiltonian. Here lambda is that parameter. Hamiltonian eigenvalue equation is that H0 plus lambda H prime is the Hamiltonian, and to the eigenvector and En eigenvalue, and here it is like this. Then we assume that the energy eigenvalue can have the order, zeroth order, and first order, and second order, and third order, and so higher order. Like this, and the eigenstate also can be expanded like first order, zeroth order, first order, second order, like this. And here our assumption is like this. Then let's apply this expression, Hamiltonian H0 plus lambda H prime, and the eigenstate, and 0 plus lambda, and 1 plus lambda square, and 2, and so on. Then energy eigenvalue, En0 plus lambda En first, and lambda square, En second, like this. And also this energy eigenstate as the same, like this. So, and in this case, and we can multiply and H0 like this, and the lambda here, and the En0 here, and here, like this. We can expand, and there are many terms. So we can categorize that let's the order of the lambda 0, zeroth order. In this case, H0, N0, then En0, N0 is the zeroth order of lambda. Then it means that H0 minus En0 to the N0 equal to 0. Then let's consider for the lambda first order. Lambda first order is that H0 to multiply lambda N1, and also lambda and N0, and En0 and lambda, and the lambda En1 and N0, it is a first order. So H0 N1 plus H prime N0, then En0 to N first order plus En1 N0. Okay, then when we summarize H0 minus En0, it is a basis is first order energy eigenvector. Then here En1 minus H prime N0 like this. Then we can understood that here is zeroth order energy and the first order eigenvector, first order energy and the zeroth order eigenvector. And like this, let's consider for the lambda second order. Lambda second order like this, H0 to the N2 plus H prime and N1, and then En0 N2, here the zeroth order energy, second order eigenvector, first order energy, first order eigenvector, zeroth order energy, second order eigenvector, and first order energy and the first order eigenvector and second order energy and zeroth order eigenvector like this. Then we can also summarize H0 minus En0 N2 equal to En1 minus H prime N1 plus En2 N0 like this. Like this, and the order of lambda 3 as H0, we can zeroth order energy and the third order energy eigenvector, first order energy and second order eigenvector, then zeroth order energy and third order eigenvector, and the first order energy and second order eigenvector, second order energy and the first order eigenvector, plus third order energy and the zeroth order eigenvector. Then we can summarize like this: H0 minus En0 and 3 is that En1 minus H prime N2 plus En2 N1 plus En3 N0 like this. And the order of energy can be expanded. So it is a general formulation. And here at first we should consider for the first order energy. Let's consider for the first order energy, and here we consider for a system with n energy levels. Then the n energy levels, it means that it is n-dimensional Hilbert space. So this energy state is 1, 2 until the nth level. So we are only focus on the order of lambda. Then we already calculated the order of lambda here. Then we already know that the Hamiltonian is a matrix. Then what is the how about the matrix? And the H0 is the diagonalized energy matrix E10, because it is the nth level, E10, E20, E30 like this. and the other term is 0, only diagonalized. Then H prime is undiagonalized, and in general H11 prime, H12 prime, H13 prime, like this, H21 prime, H22 prime, H23 prime, like this, H31 prime, H32 prime, H33 prime, like this, and like this, and like this. So in general, and when we write down as a matrix element, Hij prime component is that H prime with the basis of Hith in the jth state. For example, let's choose for the n equal 3. Then the energy eigenstate for 3 state is that 0, 0, 1, 0, like this here. Here we are interested in the n equal 3 state and the first order state, but we don't know the first state. So in this case, and the matrix element has a vector space, vector representation, C31 first order, C32 first order, C33 first order, like this, and because it is a vector. And here C3M state first order is that M0 and 31 state. It is natural that E30 is a known state, known energy eigenvalue, but the first order energy, it is unknown eigenvalue. And we should keep in mind that initial energy eigenstate is that here, this one, okay? Then, because it is n equal 3 state, H0 minus E30 state for n equal 3, 1, then it is E10 minus E30, E20 minus E30. Then third one is that E30 minus E30 should be it is 0, and here it is important. And E40 minus E30, then here it is left hand side matrix element, and here it is N0 state. N0 state is it is left hand side, and it is also diagonalized. H0 here it is unperturbed energy, it is diagonalized also, 0 diagonalized. And also eigenvalue for first order, we choose that C31 first order, C32 first order, C33 first order, C34 first order. Yeah, okay. Then the energy, here the right hand side like this. Right hand side can be Here it is n equal 3. Then this right hand side, this energy Hamiltonian, it is E3 1 minus H11 prime E3 1 minus H22 prime and E3 1 minus H33 prime E3 1 minus H44 prime, like this, and also here minus H21 prime minus H12 prime minus H13 prime minus H14 prime, like this, and minus H23 prime minus H24 prime minus H31 prime minus H32 prime minus H34 prime minus H41 prime minus H42 prime minus H43 prime, like this. And also this vector vector is same way and same, like this. Okay, but here I'm sorry, it is not. Here it is 3 0. 3 0 is that here 0 0 1 0, like this. Yeah, then it is when we calculate this matrix representation in the this term like this, then we can write down as the E10 minus E30 C31 first order, E20 minus E30 C31 first order, and here is a 0, E40 minus E30 C31 first order, like this. You go like this is matrix. And also here, let's keep in mind that degenerated case is a 0. Then in the right hand side is that minus H13 prime minus H23 prime E31 minus H33 prime minus H43 prime, like this. Therefore, and here it should be 0. So E31 minus H33 prime should be 0. In other words, E3 first order equal to H33 prime, then it is H prime bracket as a basis of 3 0 and 3 0, like this. Here when we calculate like this, and we can generalize the energy eigenvalue for the first order is that the Hn prime, then it is H prime as a basis of n0 basis. So it is very important that the first order energy correction is the expectation value of the perturbation in the unperturbed state. Here it is it is expectation value of perturbation in the unperturbed state. Okay. Let's have an example. Here sodium nucleus has a spin 3/2, and magnetic moment of sodium is that gyromagnetic ratio of sodium E m over 2 m proton mass and s. Here gyromagnetic ratio of the sodium is the 1.48, and the magnetic field along the static magnetic field along the g direction. Here consider further perturbative magnetic field. Perturbative magnetic field is applied and applying B1G in the same magnetic field. Let's find that first order energy shift. Then let's find the first order energy, and here the unperturbed Hamiltonian minus mu dot B 0 is that minus omega 0 Sg. Then this we already know that the energy eigenstate is E10, E20, E30 like this, and the E40 and the diagonalize 0, 0. Here because spin 1/3 and the degeneracy is 2s plus 1, so it is degeneracy is 4. That's why the energy eigenstate is 4. 1, 2, 3, 4. Here the spin is 3/2 h bar omega 0 and 1/2 h bar omega 0 and minus 1/2 h bar omega 0 and minus 3/2 h bar omega 0 like this. And we can understand that there are 4 energy levels. And also in this case the energy eigenstate of Sg is that the first state for the unperturbed state is spin 3/2 state, and second one it is a 1/2, and the 3 state is minus 1/2 state, and the 4th state is minus 3/2 like this. The perturbed Hamiltonian H prime is then minus mu dot B prime, then minus omega 1 Sg. Then it is that here minus 3/2 h bar omega 1 minus 1/2 h bar omega 1 1/2 h bar omega 1 minus plus 3/2 h bar omega 1 like this, and it is also diagonalized. Then the first energy correction is that Hn prime, so it is H prime under the basis of H0 N0. So the energy eigenstate. First energy is that minus 3 half h bar omega 1, and second energy, first order, is that minus 1 half h bar omega 1. Three state first order, 1 half h bar omega 1, and the fourth energy for the first order, and 3 half h bar omega 1. And so like this, and we should remember that the first order energy correction of the perturbed Hamiltonian, it is like this. It should be remembered.